Okay, as with all modelling questions, we're using the same math skill, but we've just got a different function that we're applying it for. So in this case, it's suggested that the height in metres of a tide above the mean sea level is given approximately by the rule the height of water is equal to 4 sine pi on 6t, where t is the number of hours. Draw the graph first. So whenever we're sketching a trig function, identify amplitude and period. Now, the period is 2 pi on the end value, which is pi on 6. So that's equal to 2 pi times 6 on pi, which is equal to 12. So often with our modelling, we end up with an integer value for our period. In this case, t represents 12 hours. So that's a fairly common occurrence. So amplitude of 4, period of 12. So if I just do, that's 12 to there. I had to sketch it over 24, so let's just do a second period there in a different colour. And that's 24. So we know, because of all the symmetry, if that's 12, that point there is 6. Halfway to that point is 9 hours. Halfway to that point is 3 hours. Everything goes up by 3 hours, doesn't it? 18, 21. All right, so there's our graph. We've got a maximum depth of 4 metres, minimum depth of -4 metres. We've got our time axis and we've got our height axis. So when was high tide? Well, just from the graph, we can see at t equal to 3 or t equal to 15. Now, when you could argue that it's really asking you for the time, so we should settle for 3 a.m., 3 hours after midnight, and 3 p.m., 15 hours after midnight. What was the height of the high tide? Well, just from the graph, clearly it was 4 metres. I spell it that way. What was the height of the tide at 8 a.m.? So first things first, at 8 a.m., t is equal to 8. So we need to work out h of 8, which is given by 4 sine 8 pi on 6, which is equal to 4 sine of 4 pi on 3, which is down there, pi plus pi on 3. So it's a 4 times sine pi on 3. Now sine is negative in that quadrant, so -4 times that, and sine pi on 3 is √3 on 2. So -4 times √3 on 2, which is equal to -2 √3 on 2. So after 8 hours, which is about there, it seems reasonable that we have a negative answer, so that's okay. Now, a boat apparently can only cross the harbour when the high tide is at least 1 metre above mean sea level. When could the boat cross on the first? So 1 metre above. So 1 metre might be, there's my 1 metre line. Maybe I should have used a different colour. Yellow's not much better. So I can cross between those crosses there. So first of all, I need to find out when the function is equal to 1. So that's a problem. So I need to solve, what do I want to solve? I want to solve 4 sine pi on 6t equal to 1, which means sine pi on 6t has to equal 1 on 4. So straight away, because that's a quarter, I'm wondering if whether or not that was meant to be 2. Because that's a quarter, we can't solve that without a calculator. So let's go to my calculator. Okay, so a quick shortcut to the calculator shows us the solutions there if we find that. Notice, I guess the main thing there for me is I restricted the domain to be between 0 and 24. That way I could get my specific answers and not a general solution. So what that means is that each of my intercepts occur at those points. So when could the boat cross between the harbour? So it's point. So these are my T values at 0.48. So when? So 5.5. 5.5 is basically 5.5 hours. 0.48. I reckon we'll call that 5 hours 31, and we'll go for 0.48 as 0.29. So means our boat could cross from 0:29 to 5:31 a.m. and from 12:29 to 5:31 p.m. Okay, so I reckon that's a typical sort of modelling question for trigonometry. Often it's tides or swinging periods and depth of water and things like that. And often we need to convert our answers into a time frame. All right. Things to keep an eye out for. In this case, T was the number of hours after midnight. So T equal to 2 meant 2 o'clock. T equal to 3 meant 3 o'clock. Sometimes T might represent the number of hours after 6 a.m. or something like that, which means if T was 3, well, 3 hours after 6 a.m. would be 9 a.m. Things like that. All right, good luck with it.